Welcome students, welcome to my channel Chemistry with Tarunya. Today we are going to discuss a very important named reaction known as the Carbylamine reaction, which is also called as the isocyanide test. Now what is an isocyanide? Isocyanide is nothing but an NC functional group attached to an aryl or alkyl group. Now this test is used to distinguish between primary, secondary and tertiary amines. Most of you already know what is a primary, secondary or tertiary amine. Those of you who don't know the difference between these three, I will explain it very briefly. Now, primary amine is nothing but an alkyl or aryl group directly attached to the amino group, functional group. Now, when there are two aryl or alkyl groups attached to a single amino group, that becomes a secondary amine. Tertiary, in similar lines, when there are three aryl or alkyl groups attached to a single amino functional group, it is known as a tertiary amine. Now why is it used to distinguish? Because only and only primary amines give this test. They form isocyanide, which gives a foul smell. Now what happens in this reaction is a primary amine is reacted with chloroform in presence of alcoholic KOH, and heat will form isocyanide plus 3 KCl plus 3 H2O. Okay. Now let us look at the reaction once again. One molecule of primary amine is reacted with chloroform in presence of alcoholic KOH and heated to give one molecule of isocyanide, 3 molecules of KCl and 3 molecules of water. Now what happens in this reaction is alcoholic KOH is used. Now why is alcoholic KOH used and not aqueous KOHs? Alcoholic KOH helps in elimination of H plus ions from the molecule. If in a reaction aqueous KOH is used, it means it is used for substitution. Substitution is done by the OH minus group. Now, what happens here is the OH minus of KOH is going to abstract the H from chloroform, thereby moving this bond between H to the C, giving it a negative charge. Now, because of the negative charge, it makes Cl an excellent leaving group because of the electronegativity, and it's going to leave as Cl minus and attach itself to the K plus present in the solution, thereby forming KCl. Now what will be left is CCl2. This is called as dichlorocarbene. Now this is a very important molecule because this is what actually starts the reaction. Now how does it actually start the reaction? Let us see that. CCl2 has a lone pair of electron on carbon. Now its octet is not complete, so it needs stability. For that it needs to form a bond. Now nitrogen has one lone pair of electron on it, so they form a bond. But as nitrogen forms a bond and gives away its lone pair of electron, it gains a positive charge and carbon gains a negative charge. Now because of that, the OH of the second KOH molecule abstract one hydrogen from the amine side, forcing the bond to move between nitrogen and carbon and helping in the removal of Cl minus, which attaches itself to the K plus present in the solution. thereby forming the second intermediary product like so. One molecule of water formed, one molecule of KCl formed. Now again there is one H present. The OH minus of the last or the third KOH molecule abstracts this H, thereby forcing there to be a triple bond between nitrogen and carbon and removal of Cl to form one molecule of KCl, thereby forming our isocyanide product. Plus one molecule of water plus one molecule of KCl. The same reaction can be done for aryl amine, aryl primary amine. Now let us count how many number of molecules of KOH are used. First molecule of KOH is used for converting chloroform to dichlorocarbene, which starts the reaction. Second KOH is used to change the intermediary product, first intermediary product to the second intermediary product, and the third KOH is used to transform the second intermediary product to the product. I hope this clarifies carbylamine reaction for you. If you have any doubts or queries or suggestions, please leave it in the comment box. Do not forget to like and subscribe to our channel. Do press the bell icon for further updates. Thank you very much.